Something is not right beneath southern Italy right now. Not something you can see, not something the evening news is warning about. But deep under the ground of Campi Flegrei, a slow, silent movement has been building, and for years almost no one saw the full picture. Scientists believed they were tracking the situation closely, counting every tremor, every signal. The numbers seemed serious, but still within expectations. Then, everything changed. When new analysis finally revealed what had really been happening beneath the surface, the scale was not just underestimated. It was almost entirely misunderstood. Thousands of hidden earthquakes patterns no one had clearly mapped before, and a structure forming underground that raises far more questions than answers. This isn't just another geological update. It's a shift in how we understand risk beneath one of the most dangerous volcanic systems on Earth, and it may be happening faster than expected. Stay with Climate Update to follow every critical development. Subscribe now so you don't miss the next update as this situation continues to unfold. Campi Flegrei is not a typical volcano. It is a vast supervolcanic system stretching beneath the densely populated region west of Naples, Italy. Unlike a single Mahroot-shaped peak, this caldera spreads wide and shallow, with entire towns and cities built directly on top of it. More than 3 million people live within its broader zone, and hundreds of thousands wake up each day in places like Pozzuoli without realizing what lies beneath their feet. For years, Italy's National Institute of Geophysics and Volcanology has been closely monitoring this system. Sensors track ground movement, gas emissions, and seismic activity around the clock. On the surface, this constant surveillance creates a sense of control, a belief that any major change would be detected in time. Small earthquakes have become almost routine, and gradual ground uplift has been treated as part of a known pattern called bradyseism. But here is the uncomfortable reality. Everything we thought we were seeing may have only been a fraction of what was truly happening underground. If this topic caught your attention, you can leave a 9 in the comments to follow, along with the next updates. For years, the numbers seemed clear. Monitoring systems beneath Campi Flegrei recorded around 12,000 earthquakes over a defined period, a figure that already raised concern among scientists. It was enough to confirm that the system was active enough to justify constant observation, but still within a range that could be studied and modeled. However, traditional seismic monitoring has limitations. These systems are designed to detect stronger, clearer signals, the events that stand out above background noise. Smaller tremors, overlapping signals, or rapid microquakes can easily be filtered out or missed entirely. In a complex environment like a supervolcanic caldera, that blind spot becomes critical. What scientists were seeing was only the surface layer of activity, the louder, more visible portion of a much deeper process. Beneath that, thousands of weaker signals were occurring silently, too subtle for conventional methods to capture. At the time, no one realized that the real picture was far more complex and far more concerning than the data suggested. Everything changed when researchers applied artificial intelligence to the exact same seismic records collected beneath Campi Flegrei. Instead of relying on traditional filters, the AI model was trained to recognize patterns across millions of earthquake signals, including those too small, too fast, or too complex for conventional systems to detect. When the analysis was complete, the result was not a minor correction. It was a complete redefinition of what had been happening underground. The original estimate of around 12,000 earthquakes was replaced by a new figure: more than 54,000 events hidden within the same dataset. These were not new earthquakes. They had been there all along, embedded in the recordings overlooked because they fell below the detection threshold of older methods. Each signal represented a small release of energy, a subtle shift in the Earth's crust, quietly building a much larger pattern. What this revealed was not just more activity, but a system far more dynamic and far more unstable than anyone had previously understood. At first, it might sound like a simple correction, a larger number replacing a smaller one. But the reality is far more serious. Discovering over 54,000 earthquakes instead of 12,000 does not just update the data. It changes the entire framework scientists have been using to understand Campi Flegrei. Every model, every trend line, every risk assessment built over the past decade was based on incomplete information. Patterns that once appeared stable may no longer hold. Signals that seemed isolated could now be part of a much larger, continuous process. It is not just that something was missed, it is that most of the story was never seen at all. A useful way to understand this is to imagine analyzing a complex system with only a fraction of the data available. Conclusions might appear logical, even precise, but they are built on gaps. Now, with a more complete data set, those gaps are closing, and what is emerging is far less predictable than expected. When scientists mapped all 54,000 earthquakes together, they did not just see a denser cluster of activity. They saw a structure. For the first time with this level of clarity, a nearly perfect circular pattern emerged beneath Campi Flegrei, a ring fault tracing the outer boundary of the caldera. This feature had been theorized for years, but never observed so distinctly. A ring fault is not just another crack in the earth. It represents a major structural boundary, a zone where stress accumulates along the edges of a volcanic system. Under the right conditions, it can act as a hinge point, the line along which the ground above may begin to shift or even collapse inward. What makes this discovery more concerning is that the fault does not appear dormant. The distribution of earthquakes suggests ongoing activity, indicating that pressure is not only present but actively interacting with this structure. Instead of isolated tremors, the data now points to a coordinated system, one where stress is being organized along a boundary that could play a critical role in how the entire caldera responds in the future. Beyond the circular structure of the ring fault, another detail emerged from the data that raised even greater concern. Beneath the city of Pozzuoli, two previously unmapped fault lines appear to run directly toward each other, converging at a point underground. This is not just a structural curiosity, it changes how stress behaves in that area. When a single fault accumulates, pressure energy can disperse along its length. But when two active faults intersect, that energy does not spread in the same way. It becomes concentrated, building faster and releasing more abruptly. In a system already experiencing uplift, constant seismic movement, and internal pressure from below, this convergence creates a zone of amplified instability. What makes this especially critical is the location. Hundreds of thousands of people live directly above this intersection in an area where the forces beneath the surface are not just active, they are interacting in ways that are far more complex than previously understood. The pressure beneath Campi Flegrei is not theoretical, it is measurable, and it has been building for years. Since 2005, the ground across parts of the caldera has risen by more than 1.4 meters. That kind of uplift does not happen randomly. It reflects a sustained force pushing upward from below, driven by a hydrothermal system where heated fluids and gases expand and press against the overlying rock. What concerns scientists is not just the total rise, but the rate. Instead of slowing down, recent measurements show that the uplift is accelerating. The ground is rising faster now than it did in earlier phases, suggesting that pressure is not being released efficiently. This creates a critical imbalance. Energy continues to accumulate while the system shows no clear sign of stabilizing. Combined with the growing number of hidden earthquakes and the structural features now revealed, the uplift becomes more than a background signal. It becomes a visible indicator of a system under increasing strain. Dua, Valbai Kanten, Min Kunkep, Hivit Fan 9 Morung 150. 2. Fan 9. Dungdut Gunday 152. In recent months, that pressure has begun to show itself more clearly at the surface. A magnitude 4.6 earthquake struck the Campi Flegrei area, marking the strongest event in this ongoing phase of activity. It was not just another tremor. Buildings developed cracks, and residents were forced out into the streets in the middle of the night, uncertain of what might come next. Events like this are often expected to release built-up energy, allowing the system to stabilize, even temporarily. But that is not what happened here. Monitoring data showed that the ground uplift continued almost unaffected, as if the pressure below had barely changed. This raises a critical concern. If one of the strongest earthquakes in the current cycle could not significantly reduce the stress within the system, it suggests that a much larger amount of energy remains stored underground, still waiting to be released. Beneath Campi Flegrei, the issue is no longer just pressure, it is structural change. The hydrothermal system is forcing superheated fluids and gases, mainly carbon dioxide and sulfur compounds, upward through the rock. Instead of escaping cleanly, much of this gas becomes trapped, dissolving into the surrounding material and altering it from within. Over time, this process weakens the rock itself. Scientists refer to it as rock embrittlement, a gradual loss of strength where solid structures begin to fracture more easily under stress. Each small crack reduces resistance, making it easier for new fractures to form and expand. This creates a cascading effect. The more the rock weakens, the less pressure it can contain. And the less it can contain, the more the system destabilizes. What is happening underground is not just buildup. It is transformation, where the very structure holding everything together is slowly losing its integrity. At this stage, the question is no longer just about a possible eruption. Some scientists are considering a different, potentially more immediate scenario: structural collapse. If the ring fault becomes fully activated under rising pressure, the center of the caldera could begin to give way. This is not without precedent. Around 39,000 years ago, a major collapse event reshaped this entire region. It did not unfold slowly or predictably. It was sudden, driven by forces that reached a critical threshold beneath the surface. What makes the current situation more complex is the combination of factors now in play: ongoing uplift, a high density of hidden earthquakes, weakening rock, and intersecting fault lines. Together, they form a system that may not fail in a single, simple way. The uncertainty is not just about if something will happen, but how it might unfold when it does. Right now, Campi Flegrei stands in a state that scientists understand better than ever, and yet cannot fully predict. Advanced tools, including artificial intelligence, have revealed hidden layers of activity that were invisible for years. But with that clarity comes a new kind of uncertainty. The system is more complex, more dynamic, and less stable than previously believed. No model can currently define an exact timeline. No system can confirm whether the next shift will be gradual or sudden. What is clear is that the conditions beneath the surface continue to evolve day by day. For those living above it and for those studying it, the same question remains unanswered. How much time is left before the system reaches its next turning point, and what will that turning point look like? Stay with Climate Update for clear, fact-based coverage as the situation develops. Each update breaks down what matters without noise or exaggeration. Subscribe to Stay Informed with real data, real analysis, and timely insights you can rely on as new information continues to emerge.